Now we're going to take a look at the binomial probability calculations in Excel. So the binomial distribution function in Excel can actually work in one of two ways. It can be cumulative. In other words, it's calculating the probability that x is less than or equal to a given value. And we do that by denoting it as true. Or it can be standard. In other words, probability that x is exactly equal to that given value if we denote it as false. So the command equals binom.dist, then open parentheses. Now it says number of successes. So this is the x value that we would talk about when we were talking about the calculator. We need a situation here for this to really make sense. So let's put a situation up here. Let's say that nationally, 43% of all high school seniors participated in at least one sport. If a simple random sample of 40 high school seniors is selected, find. So let's do the probability. Call this question 1. That exactly 15 participated in sports. So this is probability that x equals exactly 15. So this is the probability of a single value. So we're going to use the binom.dist, open parentheses, number of successes. Well, this is the x value. X equals 15 here, so that would be 15. Number of trials. This is the n value. So remember, trials are often the sample size. There were 40 high school seniors in the sample, so n is 40. P is the probability of success on a given trial. That's where the percent comes in, the 43%, so 0.43. And then cumulative, this does not need to be cumulative. We just want it to be a standard, a single probability, so we enter false here for cumulative. So that's going to give us just the probability of being equal to 15 and nothing cumulative. So problem 2, the probability that no more than 15 participated in sports. So this is 0 up to 15. The 15 is included. So this is going to be equal binom.dist. Still going to be 15 successes and 40 trials. Probability of success is still 0.43, but this time it is cumulative, so we'll list it as false. Or sorry, not false. We should list that as true because it is cumulative. Let me get that in there correctly. And notice a significant difference there. Now, one of the nice things about this formula is we can actually use it to create a distribution. Now, for any situation like this, we got to remember that we start at 0, and then we'll count up to the value of n, which is 40. Let's go the other way. I went way too far with that real quick. So there's 40. So this is the value of x. It's going to be p of x equals binom.dist. The number of successes is just the x value, so I'm just going to click on that x value, comma, still 40 trials, 0.43 probability of success, and I'm going to do false here. I'm going to leave this as just standard probabilities. So the probability of being 1 is very small. What that is saying, that 1.71789 e negative 10, what that is really saying is 1.718 times 10 to the power of negative 10. In other words, the decimal point is being moved over 10 spots to the left. So that's really saying 0.0000000001718. Oh, let's format that cell so it shows up as not scientific notation. Format it so it doesn't have. There. So you can see that's what it represents. Anyway, back over here, we're just going to fill that down to get the other probabilities in there. And so you can see there's a lot of probabilities here that are really small. And the really small numbers, the probabilities are very tiny. And up in the really big numbers, the probabilities are really tiny. If we switch this over to cumulative, so the probability we're less than or equal to x, the only thing that's going to change in our formula here is we're going to put in true instead of false. Notice the first probability is the same because being less than or equal to 0 is just the probability of being equal to 0. But the next one, we're adding them together. And so if we keep going all the way up to 40, first of all, the probability of being less than or equal to 40 better equal 1. In fact, once we get up here, this is so close to 1 that it just rounds it to 1. Let's go up to 15 here. You can see on 15, there it is. The probability of being exactly equal to 15 is 0.100785488. And the probability of being less than or equal to 0 or 15 is 0.295725, whatever. Exactly what we had calculated over here. So then this function is going to work just like any of our other calculations then. Let's say I want to find the probability that between 12 and 20 participated. I'm going to put in inclusively here. So that means the 12 and the 20 are included. So that's the probability that that 12 is less than or equal to x is less than or equal to 20. Now to make this work in the calculator, we have to have everything as less than or equal to. So the less than or equal to 20 is fine. What we're going to subtract out, though, is what's less than or equal to 11, because the 12 stays in the probability. And so the calculation here is going to be equals binomial.dist of 20 successes in 40 trials with a 0.43 probability, and true, because we're doing cumulative, minus binomial.dist. We're subtracting out up to 11. We're leaving 12 in with 40.43 probability and true. And there we go. If we were to add up from 12 to 20 over here, let's just do a sum over here quick. That's exactly what we get. What if we want to go between 12 and 40 exclusively participating? Now the 12 and the 20 do not get included. This is the probability that 12 is less than x is less than 20. So now the one that we want to adjust, we're actually going to actually adjust both of them. This probably the x is less than or equal to 19 because the 20 is not included. And now we're going to subtract out up to the 12 because the 12 is also not included. So this will be equal to the binomial.dist of 19, comma 40, comma 0.43, and again true because we're using cumulative probabilities here. Then we're subtracting out up to 12. And there it goes. Let's do a double check over here on our distribution. We're going to do the sum from 13 to 19. And there we get that same value. So if those of you that have used the graphing calculator for any of these, and if you looked at some of my main video, this behaves exactly like the binomial CDF in the graphing calculator. So with that, hopefully that works well for you. If you have any questions, please let me know. Otherwise, we'll see you in our regularly scheduled class.